see what this does. Ta-da! Welcome back to Arcade. I am Super Tommy, and this is the final part in our winter side-scrolling platformer in Phaser 3.50. Now in the last part we added our snowman enemy. So the snowman is walking around, we can add a whole bunch of them to our level. We can run into them and get hurt, lose health. We can stomp on them with a very basic logic check for that. So now we are going to add a game over screen and a die animation when our penguin goes to 0 health, when this bar goes to 0. So first, let's add a new animation for our penguin. So we're in the Playercontroller here, and we have a die animation, which is I think about 4 frames long. Let's go here to our penguin.json. Let's go smaller. Atlas definition here. So we got penguin die 0, 1, 2, 3, 4. So let's use that to make an animation. So like we've done before, this.sprite.anims.create, and let's just call this player def. Player def, and then frames, and we're going to do sprite.anims.generate frame names. The key is penguin. This is again the texture that we're getting these frames out of. There will be a start, there will be an end, there will be a prefix, and there will be a suffix. Now we saw here it goes from 1 to 4. So it's going to be start 1 and 4, start 1 and 4. Now the prefix is going to be this part. So we can either include the 0 or not include the 0. If we don't include the 0, so if you, let's say your animation has 20 frames, including the 0 wouldn't work if it goes from 1 to 20. So we cannot include the 0. Then we're going to have to add 0 pad, and let's just say 0 pad, hold on, 0 pad 2, I think. Let's see, what does this say? Yes, 0 pad 2. So it'll do 0, 1, 0, 2, 0, 3, 0, 4 for us, and then the suffix is just .png. We go here, it just prefixed the number .png. And there we go. Let's make a frame rate. I don't know, 10. 10 frame rate. Not going to repeat. So when we get to 0 health, we're going to play this animation and then do some other things, like turn off our hit detection so that we don't keep interacting with the world, since we already did, and go to a game over screen. So now we can check this. Yeah. Collapse that. We can check when the health has gone to less than or equal to 0, except we're setting health in 2 places. So to consolidate that logic, let's make a new set health method. So you see we do it here in snowman hit on enter, as well as spike hit on enter. Let's go up here. Let's do a private set health. We're going to get a value here, and we'll do the clamp here. So just come down to spike, let's say, and we'll do the emit. Just copy this. Do that. Instead of this, I'm just going to do value. Okay. And so here, just have to do check for death. Right. We'll come back here and handle that. First, let's just finish our refactor. So instead of this, it was this.health minus 10, that's the new value. This.setHealth, this.health minus 10. Now I think we had it the same for our snowman, minus 10, but if you had a different value, like let's say minus 25 for your snowman hits harder, then we can do that. And so now, you'll have to realize this, we'll realize this later, but note that we're setting the state after we call set health. Just keep that in mind. Okay, so now let's just play this and make sure it's still working, right? We're losing health, so we can get health back. Oh, I wanted it. Does it get hurt by the snowman? There we go. Okay, so that's still working. So our health is still working after a refactor. So now we want to do is check in set health. Let's come back up to set health. So if this dot health is less than or equal to 0, now we know it's not going to be less than 0 since we clamp it here, but it doesn't hurt to do this check anyway. And then we're going to want to do in our state machine set state to, let's just call it the dead state. Now we got to make the state, so we don't have it. Let's come here, add state dead, and we're going to have an on enter, so dead on enter, or this dot. Now we got to make the dead on enter method. Let's go down to the last one here. I just like to organize my states if I'm doing it this way in the order that is listed, but you don't have to. Okay, so when dead on enter, so this dot sprite dot play, so we're going to play this player death animation, player death, and then we want to stop moving. We're going to go to the game over screen as well after some time. So let's just say, let me do that, see what happens. You'll see this is going to work only moderately okay. Maybe not okay at all. So to make this happen quicker, let's just make our spike kill us immediately when we touch it. So this is the spike, we're going to subtract 100 health. Come down here, and as you see, Penguin is not dying. He has no health, but he can still walk around like a zombie. So here's the issue, and what I mentioned a few minutes ago to keep in mind. So we call set health. It's another method now. Now we do set state. Let's go back up there. We do set state to dead, right? Which is great. But let's go back to the spike. Hit on enter. We set state to dead. Great. Now it's in the dead state, or it's going to go to the dead state. We do all this logic, and then down here we say go back to idle. Now there's a couple of ways to handle this. You can either say, you can do a check here. If state machine, like this, if this dot state machine dot is current state dead, if not dead, then go to idle, right? Like this would be fine. This would work. Another way, so let me just show you that this will at least not. This didn't work as I intended. There's probably some other places also setting it. So that's why we're going to have to do this in a few other places. So actually, if I turn this, but what you see logically is happening is it's setting it to dead, coming down here, and then setting it back to idle. Now what's also happening is that in the set on collide, it's also setting state, right over here. This set on collide. Like it has collided with the spike, it did some things, it lands back on the spike, and it's gonna set itself again. So we don't want those things to happen. So we could do that wrap here for this. Another thing we can do with state machines is actually add transitions. Now we're not going to cover that in this video, but it is a popular method of using state machines is to add not only states and then just going from state to state as you want. You add transitions that define exactly from what state can go to another state, and then you would just do run transition or dot transition or whatever, and it'll do that state transition. Now we're not going to do that in this video. Instead, we're just going to move this, since our logic doesn't actually matter val that much here. When that set health gets called, we'll just bring it down here, so that it can say set state idle, but then we're going to go to set state dead if the penguin happened to have died during this code execution here. So we're going to do that, and what we got to do in dead is make our set on collide a no op. Now you may see this on the internet or other tutorials. You may read it out as noop, right? No op, no op. And no op in this case is referencing a function that we can pass into the set on collide that does nothing or no operation. So let's go this.sprite.set on collide. Now this is the no op. Oops. Here's the no op, right? It does nothing. This is a function, takes no parameters, does no logic in it. It's an empty function. And so then it'll do nothing. Now let's see what this does. Ta-da! So our penguin got hit, and of course now we can't actually move because we are in the dead state. The dead state doesn't listen for anything. You see dead, there's no dead on update. Once it goes to enter, it goes to dead on update, and you'll see for the penguin at least, if I can come here, idle to dead, and it's going to just stay in dead, in that dead state. And we get the no op on the on collide, so it doesn't now send you back to different states when you re-land on the spike since you're already dead. So that solves that problem. Right now you're dead. So now when we get here, we do eventually want to go to another scene, right? So let's just say we make a game over scene, but we don't have that yet. So this is not going to work. So let's add it to do, go to game over scene. So let's make a game over scene to go to. Let's come out here in our scenes. Let's just make a new file, gameover.ts. Now let's import phaser from phaser, and then we're going to export a default class, gameover. It's going to extend phaser.scene. Got a constructor like the other scenes we've made in previous parts of this series. I'm going to call it gameover. We'll do a create. We'll just real quick add some text that says game over. So this.add.text, and we'll just put it in the middle-ish. So width, height here, we're going to get it out of the scale manager. This is object destructuring, so this.scale, that's the scale manager. We're going to get width and height out of it. Then we're going to put the text x at width half, so that's the center of the screen. And then height, we'll just do a third of the way down. Say game over. And let's say text style. Let's make the font size 52 pixels. And the color, let's make it red. Now let's do set origin 0.5 so that it's in the center. Now let's make a button to play again. So we'll just make a rectangle. This is not the prettiest of all time. So width times 0.5, the middle. Height times, let's just say 0.55. Let's give it a width, let's say 150 by 75. Color, we'll just make it white, and then there we go. And we'll do set interactive so that we can click on it and get mouse events on it, and then on phaser.input.events.pointer up. So we want game object pointer up so that when the pointer is released on the game object, this gets triggered. And what this will do is play again. So this will just do this.scene.start game. So just restart the game scene. And now let's add some text. So we'll just do const button. Now we're going to use this button to get the X and Y and put text directly on it. So this.add.text button.x, button.x, button.y. So text is just play again. Let's see. Style, let's just make the color black. So black is the absence of color. So that's 0 for everything. Okay, so now let's go to our main.ts and add our game over scene into the scenes list, or the scene list, like we've done with the UI scene before. So game over, oops, scene/game over. Okay. So we have our game over scene. Now let's go to Playercontroller here. Now we can do this. Now let's see what happens. Died too fast. Okay, so this is a bug. Our UI is still there. That's game over. This is not aligned correctly, so we do set origin. So that's what this set origin does. Text by default is top left. That would be origin 0, 0. We want it to be 0.5, 0.5 with the center. Now he's dying too fast. This looks good. That goes back to game. Now it's dying too fast. Let's go to game. We're not dying too fast. It's not showing us the animation that we want to see, the death animation. So let's just go this.scene.time. Let's do a delayed call. Let's just say 1 second. After 1 second, so we're going to enter this dead scene, dead state, and then after 1 second, we're going to go to the game over scene. It's not even enough. Let's go 1.5 seconds. Pretty good. All right, so you got this UI here. So what actually is happening? Now, in our previous videos, we added this destroy for our scenes, but actually we've made an error in using destroy instead of shut down. So we don't actually want to use the destroy event. So let's go to game here. And we also didn't call stop on our scene anyway, but we also, this should most likely be shut down and not destroy. So let's go to UI here. Same deal. This should be shut down and not destroy. Quick fix there. Now in destroy, since in the game scene we launched the UI scene, we should also stop the UI scene. Stop. And there we go. So no UI scene. This is here. We're game overed. Play again. We're back. And probably die again. And game and play again. One more time. Okay. Now we got a good loop going on here for the game. And that's basically the end of this series. This is part 8. We've made quite a lot of stuff here, the side-scrolling game. There's a bunch of things you could still improve. Now you see this white line here. There's a few ways to fix this. One way that we talked about in previous series on the dungeon crawler is to reduce tile bleeding, is to use tile extrusion. Now, you may not need to do that. It depends on your tile set and what's going on. I think in this case we may be able to fix this simply with round pixels when the camera is following. This may not always work. Let's see here. So there's a second parameter here called round pixels. Set that to true and see if that helps us at all. And it does. In this case, we no longer see that white line artifacting. So that fixed that, at least in our game right now. Oh, and we're good. Let's actually set that back to 10. And go over a couple of more things that we may want to fix or improve, and give you some resources to do that. So that squash, right, wasn't fantastic because it doesn't check for enough things. We can also check, this is snowman hit, not only that the sprite is on top, but also that the penguin's velocity is down. Now, unless of course you do want the penguin to stomp on someone on the way up. So for example, right, that also killed it. Now if we did a check for velocity down on the penguin, it will only do it if it's coming down on the jump, versus at any point it collides with the snowman when it's above half. And like we say here with the, oh no, this is not the one, the stump, this one. And we do that logic check actually up here, over here. So this is the checking the position. And because, if I can come up to see this other snowman right here, so the XY is the middle. We can always do another offset a little bit higher so that the penguin is only going to stomp if at least the Y is above like the forehead of the snowman or something. Now, like we talked about in the snowman video, you can also add another sensor as a compound Matterjs body to even do a better stomp so that it's a smaller area to hit. Let's see, what else do we have here? This wall sliding, there is a way to resolve that as well using sensors as a compound body, compound body on the penguin, the sides of the penguin, to know when we've touched the edges. Or we can also, and then we can also reduce the size of the box here. Obviously, penguin is not this big. You can adjust the rectangle hitbox here in Matterjs to make that hitbox smaller. So there's a whole bunch of things we can still do to improve this side scroller. Now, if you've enjoyed this series, hit that like button and subscribe to this channel, and let us know what else you'd like to see in this side scroller. What other things you'd like us to show you how to do, or what you'd like to see done with this side scroller. You should be able to do quite a bit already, but let us know what else you'd like to see in the comments below. Thanks for watching, and if you enjoyed this 8-part series, be sure to hit like and subscribe for more videos on making games in Phaser 3.50.